Okay, for those of you that are joining us now, sorry, forgot to turn the camera back on. So you get most of this stuff and you can talk to your friends and they'll explain everything else. So, and apparently for $5 you can get an extra special version, the extended cut. That's what you can get. All right. So the range is the tough one when it's a parabola. And look on your chart, because now I'm going, here's my chart. What does it say about quadratics? It's the only one that's mildly difficult. Just hold on, I'll find it. So we must remember that domain, these are your X values. So if I'm coming this way, I'll eventually hit my graph and I can say that X value of -0.2 or something. There's an associated Y and there's one at 0 and 3 and there's one at whatever that is. So 1 3/4 and 2 and something, because all of these, although the graph doesn't let me do that, we assume they keep going. But if we look at the vertical component, if we come down from the top, we've got graph, 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 and then all of a sudden it's like, there's nothing down at the bottom. So on your chart, it says when A is positive, Y such that Y, okay, we're going to start with that part, because I don't want to think more than I have to. It's going to be squishy, and I'm sorry. Y such that Y is greater than or equal to. And then we find the minimum Y value. So minimum means as low as it goes. So the turning point on a quadratic is always the minimum or maximum. So this is the point, and if I go this way, can somebody tell me about how far that is? 1.7, sure. 1.7. And then I'm supposed to put XER. Whoops, no, YER. So to translate that, yes, I'm sorry, that's very, you have to be very squishy. So the range is a set of all Y such that Y is greater than 1.7 and Y is an element of real numbers. So to translate that into what that means, any Y value you pick, as long as it's bigger than this, there's going to be a graph associated. So if I say Y is 5, I can go over and I can find the graph. I can even go this way and find the graph. Or if I say Y is 3, there's my graph. And I can go down to 2, it's over here, but 1.7, I hit it. But if I go to 1, I can go as far as I want this way or as far as I want that way. And I am never, ever, ever going to hit my graph. So the range is the one to be careful with. And what we didn't talk about yesterday, although I have faith in you, is the number of turning points. And a turning point means exactly what it sounds like when it changes direction. So it was going down and now it's turning around and going up. How many times did it turn? Once, done. Ta-da! There we go. That's what this is about, analyzing, graphs. Oh. Oh. This over. Ooh, that looks cool. Okay, there we go. So, Tyrese, you're very quiet over there. What do you think? Constant, linear, quadratic, or cubic? Excellent choice. I'll put CU so that we know it's cubic. is if you go back to your notes, a constant is a horizontal line. A linear equation is just a straight line at some diagonal. And a quadratic we know is a smaller round, so it's got to be cubic. Now, the sign of my leading coefficient. So you can take a look at where it starts. So I would like everybody to just take their pencil and circle where the graph is starting. Don't overthink. It's like up here. Where is it ending? Down there. So what direction is that? If we go from the start to the end. Is that, as I go this way, is that going uphill or downhill? Downhill. So that means it's negative because this is an odd degree. I feel really bad that my line did something very weird. Because I always yell at you guys to use rulers. So if you need to know leading coefficients, you can always just find the start and the end. All right. Rihanna, your turn. How many times does it cross the x-axis? Good job. So take a moment and write those all in. Making sure you get them in the right order. Colleen, what's 1x intercept? So that's your x-axis. It's this one. So where does the red line cross the pink one? Okay, 0 and 0 is 1. So that's that one. Audrey, where's another one? No. Whoops. There, might hit the wrong spot. So 0 and 0, negative 2.5 and 0. And Lily, what's the last one? Negative 5 and 0. Did I lose you? We're good now? You got it? Okay, excellent. Colleen, you're all right now? Okay. Now we need the coordinates of the y-intercept. Rihanna. Yeah, I like 0, 0 because it's both. Therese, where's my starting quadrant? Sounds good. Where are we ending? Excellent. My domain is already done. Now my range. Good morning, John. I'm going to look over here on my chart. And here's another gift to you. See when it's cubic? Y's such as y's and elements of real numbers. So it's always the same. We don't have to throw anything in. So we just copy that. So again, because at the ends, this graph keeps going. It keeps going left and right, and it keeps going up and down. So we've got YER. Colleen, how many times does the graph turn? 2. There's one here and one here. So 2. Morning, John. This will be in your mailbox. We are working through an assignment together, at least part of it. All right. I think you guys can tackle, well, I know you can do 4 for sure, but I'm going to be quiet for a little while and you try 3 and 4. So this is what we're working on. And you can have notes, there's a chart on page 8. The other thing I told it after this is take a highlighter and highlight the X mark. I find it way easier. It helps me focus on where everything is. Ready to go? Yeah, okay. Well, you guys are doing awesome. I was just thinking at the bottom of my chart here. Okay, so this is the one on page 8 at the bottom. A constant. Okay, so it's always a horizontal line. I'm just adding the visuals. Joanne's lost without her visuals. A linear equation, it's a line. Okay, but don't make it a horizontal line. It's anything but. So that one's A is positive. That one A is negative. And you can all yell at me, Joanne, we can't see anything. Now, with our quadratic, we're going to get, they are parabolas, which is a small, so this is A is positive, A is minus. So it's going to be curves. And I wanted to bring this up because I don't think in this assignment I got one quite right. So our cubic, okay, my brain says it's going to go this way. Can either have this, okay, so this is when a cubic doesn't have a turning point. So a turning point really means you're going down and then you're going up. This is kind of, I'm going down and then it's not quite so steep and then wow. Okay. So then the opposite of that, and why am I having, trouble doing that? It would go like that, or it would go like that. So this is A is minus, because if you're going from the start to the finish is downhill, and this is A is positive. I have faith.
First one is not anything but that line up. Like the first one.
This one?
Yeah.
Yeah, it's a straight line. Done. Horizontal always. Done. Yeah. And it'll say y equals 2, so that's a horizontal line at 2 or at 4 or wherever. Okay, let's get back to work here. So now that you know that, John, can I ask, you ready? Is it a constant, linear, quadratic, or cubic? Take a guess. It's okay. Audrey, this is linear. Okay, now, Colleen, is it positive or negative? That's why this is going to help now. It's going uphill. So if we think about a little ant that starts here, he's got to crawl uphill to get that way, so it's positive. You're always reading left to right. Tyrese, how many times did it cross the x-axis? Perfect. That's right there. So that's going to be 4 and 0. Okay, who isn't yelling at me? What the heck? Yeah. That's not the x-axis. Apparently Joanne should do this too. We could add that to the you were right. -1 and 0. I was so worried about making sure I got the 0 in the right spot. I didn't even look at the right axis. Hey, but you know what? The y-axis, there's one y-intercept, and it's going to be 0 and 4. Sorry. There we go. And I'll say this now, and I'll do it at the end too. When I'm done, I'm going to look at all my y coordinates and make sure the 0 is first. And then I'll look at all my x coordinates and make sure the 0 is second. All right, starting quadrant. Rihanna. Which? Okay, Lily finishing. Yep. And the range. Audrey? Sorry, I'm just having a tough time hearing you today. Yeah, but it's not a parabola. So go to your chart and see where it says linear. Okay, there we go. So, oops, there it is. Range. So, as I said the other day, if you really get lost and you have no idea what the range is, put YER, because it's right 50% of the time. And I'm going to be lazy. I'm completely okay if you guys just put that, because there's not much room. For you, Rihanna. Yeah, you're making it? All right, how many times, Tyrese, does that line turn? No, 0. No turning points. Excellent. Okay, well, this one you guys should have done really well on. Excuse me. Because we already did a parabola. So it's a quadratic. Colleen, sign a leading coefficient, positive or negative? Excellent. Excuse me. John, how many times does it cross the x-axis? And I'm going to mark my x-axis because I keep getting it wrong. Excellent. Can you give me the coordinates, John? What's the coordinate of that one? Three and 0. And the other one, when I give this one a test, I'll try and, for lack of a better phrase, make it prettier. So this looks like about, I'm going to say 0.4. As long as it's close, so probably anywhere between 0.2 and 0.5, I'd say sure. Now my y-intercept. Lily. Good job. All right, starting quadrant. Is 2. And ending is, where does it end? Anybody? 1. Okay, cool. Oh, my range is gonna be one of those. All right. I struggle. You guys, no. You guys are not yelling, saying, Joanne, that's not even on the screen. You could say things like that for me. With greater than and less than. And I finally figured out that if it's a smile, one sec. It's great to have a smile. So I know it's the greater than. So I'm just going to go y is greater than, whoops. I say greater than, wrote the wrong sign. Greater than or equal to, and then I just have to see how far down it goes. I'm being lazy because there's not much room. How far down do we go? Someone? Sure, that looks right. Negative 2.7. So anything greater than that, we got a graph. Turning point's 1. Whew. All right, I'm gonna hush now, and you're gonna do 4, 5, 6, finish it. And then we'll go through them.
Let's try now.
Morning, Gina.
Negative. Y is less than or equal to. Yeah. I think PD also. How far up is that? What's the maximum? Like negative 20 or something. I'll try and make it for you on the exam. I'm feeling like sacrifice this.
All right, so it's a quadratic because it's a frown. It's a frown, so it's negative. Number of x-intercepts, absolutely none. That's why I find it really easy to highlight, because then I can tell. So 0, not applicable. My y-intercept is over there, so that's 0 and -4. We're starting, oh, quadrant 1, whoopsies. 1, 2, 3, and 4. So quadrant 3, quadrant 4, and oh, I got a parabola again. So y, and this time because it's a maximum, it goes up like that, or a is negative, however you want to do it. It's going to be y is always going to be less than or equal to, and then I'm going to eyeball this. So like negative 0.8-ish. And one turning point. Any questions? We're good? Awesome. Oh, this works so much better cutting this apart. All right. Okay, that's got some serious curves in it. So that's cubic. If I look, oh, hold on. I got skills. Thank you, Colleen. I have a plan. My mama taught me how to sew and I can make a pleat. There we go. Okay, so cubic. If I look here, so I'm starting here, I'm ending up down there, and that's going downhill. That seems to be negative to me. Number of x-intercepts, 2. Coordinates, -1 and 0. And oh, I'm just going to say 2 and 0. If you put 2.1, good job. Is kind of just barely over the line. Coordinates of y-intercept, that's going to be there. So about 0 and 1.5. Starting quadrant, 1, 2, 3, and 4. So we're starting in 2, ending in 4. And I know my range is YER. And 2 turning points. Question, I'm hearing. Anything? We're good? Rihanna, ask a question. All right. Rocking through this. Yes, 2. So let's put that the right direction. There's one, and there's the other one. So with cubics, the answer is either 0 or 2. If it was 0, it would kind of come down like this, and then there'd be a bit of a turn, and it goes like that. So you need distinct going from one direction to the other. Yes?
Coordinates for x, does it matter what order you put them in? Like -1 and 0 or -1?
It does matter a lot because -1 and 0 is here. 0 and -1 is down there. So order matters. And I will show you a quick trick at the end here. Okay, so this is linear, my last one. Sign of the leading coefficient, it's going downhill, so that's negative. 1 x-intercept, 4 and 0. 1 y-intercept, 0 and 2. It starts in 2, ends in 4, YER, and 0 turning points. All right, last one. That's got to be cubic. If I look the way it starts to end, that's going uphill. So that's positive. 1 x-intercept, 1 and 0. My y-intercept is 0 and -2. We're starting in 3, ending in 1, YER, and 2. Okay, so the one thing I was going to show you, because I want to have break, when you're done, because I don't, okay, I mean this in the nicest way, I don't want you to make stupid mistakes. First of all, make sure you go through and just put 1 y-intercept and XER, done. But then when you have your x coordinates of x-intercepts, make sure that the 0 is the second number all the time. That one's easy. It's, for me, it's the y coordinates I screw up because my y-intercept is 3, so I want to write that first. So just go through and do a quick check. Yeah, 0 is the first coordinate, we're good. Now, when we started, one of the other things we said is you can only start in 2 or 3, right? Because we got 1, 2, 3, and 4. These are the only ones I can start in, so go through, make sure all of those answers are 2 or 3, and then go to your end and go make sure all of those are 1 or 4. Okay. And also on your chart, you could double check your number of turning points in case that's something that causes grief. But there's never going to be more than 3. Okay, break. You come back, you write your exam.